Okay, welcome back. In this app, we're going to investigate the distribution of multiples of prime numbers. So the lowest prime number is 2, but let's just make a little mistake and pick 1. And straight away, this app is going to inform us that 1 is neither prime nor composite. It's a special number called our unit of number. So we'll choose to use red, and we look for the multiples of 2. Now, so 2 is a prime number. It can only be written as 1 multiplied by 2 in factor form. Now, as these multiples of 2 form on our 10 by 10 grid, I want you to think about the pattern. Okay, and in particular, which numbers are eliminated? How would you describe them? And the answer is anything that ends with an even number. So as we continue our search for prime numbers, we will not consider numbers ending in 1. We will not consider numbers ending in 2, 4, 6, 8, and 0. Okay. Now we're going to skip 3 for a moment and go on to 5. I'll use orange for multiples of 5. So we see 10, 15, 20, 25, 30, etc. Are being eliminated. Need all multiples of 5 less than or equal to 100 are coloured. Okay, and now we have sieved out multiples of 2 and 5. Okay, so what we learn here is that as well as not bothering with numbers ending in 0, 2, 4, 6, 8 for further searching for primes, we should also dismiss numbers ending in 5. So that leaves numbers ending in 1, 3, 7, and 9. In other words, the lower pair of odd numbers, of odd single unit digits, 1 and 3, and the upper. And we skip everything else. So let's look for a distribution of a number like 3. Now, another quick one to note is that our base is 10, and 2 and 5 multiply to 10. So that's why that's one reason why that's the reason really why they are so co-aligned and how they're taken out completely. So will there be a more tricky distribution for 3? Let's put it in blue. So we see the first column has multiples of 3, second, third, fourth, fifth, sixth, seventh, eighth, ninth, 10th. There's no particular distribution, but there is a very important pattern. Let's look for it. So let's just jump in anywhere. Let's go with 5 and 4. What do we get when we add 5 and 4? 9. Well, 3 goes into 9. What do we get when we add 8 and 7? 15. And if 3 goes into the sum of the two numbers, then you know it's multiple of 3, and that's a very powerful thing to know. Okay. Now with 7, the only two numbers of importance would be 49 and 91. Let's look at that. Okay, we'll go green with 7. Now other numbers are being taken out, of course, as well as 91 and 49, but they were already gone anyway. Again, at this stage, all composites have been removed, and we see the circulation there of the primes. Okay, now we will ignore the top decade when we're doing we'll make this list up, except we'll put the 20s together in their own column, and 30s and 40s and 50s, etc. And you'll see that later. Okay, that's it. It's a long video, but it's very, very important. It explains the fundamental principle of counting, which is that every composite number can be written as the product of primes.